Okay, this is an app. What it does is not important. Here's the preference window for this app. Oh, I'm Brian Marick. And if I double click in here, it lets me edit, and I'm supposed to put in the name of a Ruby file, like twiddle/temp/foo.rb, and it goes in there, and I can edit it again if I want. That's all very nice. That's pretty lame, of course, because what you want to happen when you double click on this cell in this table is you want it to pop up an ordinary Mac file chooser so that you can navigate around more easily and not have to worry about typos and so on and so forth. So in this next half hour, if I'm lucky and I don't mess up, I will implement that file chooser, doing it test first, because I'm one of those test first people who are too dumb to do anything longer than 5 minutes. So, yay, I'm dumb. So here is the first example of a test. I use shoulda, and I also don't use get. So I'm way behind where the cool kids are. Shoulda lets me write my test names as a long English sentence. I also use assert 2.0, which does some neat things that if I actually get done, you'll see. So let me now draw a picture of my design solution. So in a normal Mac Ruby app, everything you see in the user interface is more or less a view. So the screen area you saw was a view. The table you saw was also a view. The buttons were views, so you have views inside views inside views. And in yet another variant of the model view controller pattern, the views are controlled by controllers. So when you click on a button, the view knows what to do, and what it does is it calls a particular method on a particular controller. So it'll send a method from here, from that top thing there, down into that controller. The controller does whatever controller does, and it might stuff values into the view. Now, my first thought when I was implementing this was, well, the file chooser is just another window that's basically also a view. So all I have to do is pop open a file chooser from this controller, and so that's a view, and tell it to run modally like they always do, and when it returns, grab the value of the file name out of it and shove it back up into this view. And when I started, so it's going to go create that, grab a value, and push it up there. When I tried writing my tests for this, I found that the tests were really awkward to write. And I first heard this, I think, from Carl Erickson of Atomic Object. Their motto is, if tests are hard to write, you're doing something wrong. So clearly, here I am doing something wrong. So instead of having this controller, the controller for my preferences window, control the file chooser, I will create another controller, and it will be responsible for setting the file chooser going, picking values out of it, configuring it, whatever is required. So now what I could simply do is I could have this controller here, which is the controller that handles one window, just make a method call into the controller that handles the file chooser, which will then pop up the view and do all of that. But I discovered, as I was doing that again, the tests felt really kind of awkward. So I can't do that. So I decided that I would keep a separation of concerns between these two things, so that this little stack of view and controllers should be completely ignorant of this stack of view and controllers, and vice versa. So when this controller gets a double click and knows it has to get somehow a file name to stuff in that into the table cell, it is not going to call a method. It's going to shoot off a notification, which is something that's built into Cocoa. This is a RubyCocoa app, by the way. Notification built into Cocoa that goes off into the ether, and any object that wants to receive that notification and has pre-registered for that notification will then get it. So this controller can send a notification to this controller without knowing who's receiving it, and that separation of concerns turns out to make testing easier. And here, by the same token, when this guy gets a file, he'll shout out, hey, I have a new Ruby source file, and this person registers for it, grabs the value out, and stuffs it into the table. So that's the basic implementation strategy.
Could you send me that?
And send you what?
That awesome image you saw.
I'd love to. So, okay, oh, by the way, this all comes from a book that I in theory finished on RubyCocoa. The publishers have said I can give away 3 copies, one of which Jim Marick already took. So there are 2 more non-corporeal, because not yet published, copies that you can get. So if you want that instead of these books, you should ask me. And you can also ask for a signed copy of that picture. You have to win. In any case, here's a little example of a test, and this is how the tables in Cocoa, views in Cocoa, know about the controllers. They have pointers to their controllers, and controllers have pointers back. So here's the table. SUT is tester jargon for system under test. In this case, it's that controller. So I'm asserting that after initialization, the table's target is the controller, and the table, when it has a double action, will call this method named DoubleClick. So Objective-C is like Ruby in the sense that it's very casual about about making you declare things. So it's more like Ruby than it is, say, like Java. Okay, so that's all not very interesting, and I wrote a little bit of code here to show you how to do this, and I will show you here my somewhat idiosyncratic approach to mock objects. So a lot of people start out coding up the happy path. I will often tend to code up error paths first and leave the happy path later. This is an error path. So when I'm double-clicking on the source column, it should open a file browser, but if I double-click on any of the other columns, it should continue editing as it did before. So I have a test that checks this. So during a double-click operation, so when the table calls double-click on the controller, I want the following message. I want this message right here to be sent to the table cell. So this is the message an app sends to a table to get a particular cell in the table edited. So what I'm saying is during the processing of a double click, this table should receive this method saying edit this column, which I haven't talked about yet, but it's the name of the display column, or the index of the display column. And this row, 1999, which I haven't said how I set that either, with any event, I'm using Jim Wyrick's FlexMock package with all sorts of crud ladled on top of it. But if you know FlexMock, you'll know this means that I don't care what event gets sent back, because programmatic calls of these kinds of methods don't really need to send events. And this little thing, which should not be scrolled off the screen, is, well, it says true.toNS. And toNS is the method you use to convert a Ruby object to an Objective-C equivalent object. Now, it turns out you almost never need to use this, but Ruby has a very different idea of what a Boolean value is than Objective-C. To Objective-C, a Boolean value is just an integer with a conventional meaning. It's no different than any other integer. Much of the time, RubyCocoa can say, yes, that object there takes a Boolean value, so I will convert true into 1. In this particular case, for whatever reason, it couldn't, so I have to do the conversion myself. That's kind of life when you're crossing these boundaries. So what I'm saying here is this method with those arguments, and what you can't see on the edge of the screen should be called once, one time. And down here, this says that whatever objects are out there having registered to receive notifications, those objects never get their registration method called. So having done that, I have to pick a value for display name column index, which I did somewhere up above. I have to pick a row value for 1919. And now I have to answer the question as a coder, how do you get the row and column that were clicked in a table? And the answer is you send these two messages up here. If you send the clicked column method to the table, you're supposed to get back a column index, so I'm telling it to return this. And if you get the clicked row sent back, you should receive, if you send the clicked row message, to the table, you should get 1999. So essentially what I've done is, it turns out that it's really awkward to impossible to actually use a real NS table view object in your unit tests. So I'm faking it with what is called a mock object, which is an object I can program to respond to me in certain ways or to have certain expectations of how I'm going to call it. So here I'm saying respond this way whenever you get these methods. And here I say, this is how you better be called, mock object. You better be called this exactly one time. And if during the test the mock object isn't called that way, it throws a fit and a gigantic stack dump and does the usual I've failed unit test behavior. So that's the basic part of my test. Down here at the bottom, I check what you see in a normal, what they sometimes call state-based or Detroit-style unit tests, which are just checking that the state of the system hasn't been changed. I haven't inadvertently changed that column of sources that you saw in the original table. So I've already made this test pass. I just wanted to show it to you because it's the clearest explanation of what's really going on in these tests. Since almost all of the tests here are going to receive clicked column and clicked row, I actually shortened things up and just made a method called during double click on, and that does all that gobbledygook for you. So during double click on the display name column index, you should behold the table receiving edit column row with event blah, 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 and so on and so forth. So this is a more sensible, concise way of writing the exact same previous test. So now let's actually do a new test, which you will see. Let me just check the resolution here because, this is not a 1020, oh well. Okay, we'll bull through the resolution. Oh wait, let's just make the font a little smaller. I think I can afford that, right? Is that still legible or should I bump it? Okay. So down here, Now, at the top of the screen, here's the first test that does anything useful. So when you're receiving, that's the wrong test, sorry. This one. So when you click in the source cell of a row, you should eventually post a notification asking for a Ruby file. Should eventually tells don't run this test because it won't work yet. I know it won't work. I don't want to hear about it not working. But do remind me that you ran it so that I don't forget to ever make it run. So here is a test that now works, or now runs, doesn't pass. During a double click on the source column index, any watcher who cares about it should be notified exactly once with a particular notification. And the notification, a typical built-in to Cocoa notification, has a name. It needs Ruby source in this case, that's the string. I don't care what object should be received. And it should contain in its hash of values a row key whose value is 0. The reason why I'm passing the row in there is not really relevant to this. It turns out that when you drag and drop, this turns out to be worthwhile, but we're not going to do drag and drop, so just accept that there's a reason for passing the row here, even though the controller knows what column has been clicked. So we should do that. We should fire off that notification, and we should not start at any editing, which is a method that expands into that long edit method should be called 0 times. Okay, so in good test-driven fashion, we will run this test. TST is just something that filters out stack garbage when a test fails. So here's the failure. This method, edit column with row select blah, 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 we said it was going to be called 0 times, but it's actually called once because we haven't implemented it yet. So let's go and make this test pass. That will be done by this method. So here's the double click method. Here's the code for everything I've already passed. Now I need to add a special case for the case where the table that's clicked was the source column. And there happens to be this thing, column IDs, that maps from column numbers to column names, so I'll use that. So I want to say here, if, what was it, column IDs of the clicked column is source, we should do something, which I haven't decided yet. Otherwise, we do the thing we were doing before. So what we need to do here is actually fairly well described by this test. All the real thinking that's gone into this was in thinking what the test should check for. Now that I've thought about it, I just basically need to type it, and I just happen to know that you post a notification. This is not the real way you post a notification. Again, there's a wrapper. I've written a wrapper method around this. Cocoa methods tend to be very long, so I did a shorter one. So we need to post a notification called needs Ruby source with the row being, I'm going to say table.clicked row. Okay, so that should pass. Yay. Thank you. So the next thing to do, I thought you people liked to code. The next thing to do is now we're over on the other controller. I'm implementing this in the sequence of message flows. So when this thing, during the announcement of needs Ruby source, this thing, the chooser panel, which is the dialogue, the modal dialogue that we're going to create, that chooser panel, which already exists but is invisible, should receive run modal for types once with a list of the extensions that it should allow the user to pick, which in this case should be .rb. There's actually all this. I've got some other tests up there. Oh, this one already passes. So, well, that was good. We're done with that. We need to find this test which fails. So when a file, oh, right. So I've already written the code that receives needs Ruby source because I thought that would save me some time instead of costing time by confusing me. So once we've popped up the file chooser, it returns either OK or cancel in the usual way. And now what we want to do is when the user has chosen a file, we should announce that someone has a Ruby source with the name of the source and the row that was originally passed through. So in code terms, that means somebody's going to announce needs Ruby source. That means that the chooser panel is going to run modal for types. That also means that we're going to receive a file name. And as a result of all of that, this particular notification is going to get fired off. That is, watchers are going to be notified once with this expected value. Now, the idea of programming like this, programming with mock objects, heavily with mock objects, in its original formulation was all about helping you think through the interactions between the objects in your system. That's what's sometimes called the London style of unit testing. And many fewer people understand this than understand the state-based style of unit testing, including me. But Steve Freeman and Nat Price, who are the guys behind mock objects in this style, are writing a book. And I recommend you read it because it'll be a different take on unit testing. So in any case, we have to make this thing pass. Go away, caps lock. Now let's first make it see if it fails. Oops. So it fails because the method file name was never called. So let's look at the code, which happens to be right here. And once again, the overhead you have to go through to use notifications in Objective-C is unacceptable to a Ruby programmer, so I wrote a thing called onLocalNotification that does all the registration garbage. So when needs Ruby source comes in, this notification is passed to it. It returns unless, if the panel doesn't return an SOK button, it returns. So now we've dealt with the error case, now we're going to deal with the regular case. And the regular case was described by the test, once again. We know we need to return file name, but actually what matters is down here, we have to post a notification. We have to post a notification, has Ruby source, with the source being what came from the panel, the file name that was chosen, and the row that was passed in the original notification. Okay. Now with luck, that passes. Much better. You know, I gave a talk in Montreal once on my birthday, and I made them sing Happy Birthday. It was about a crowd this bad, and they were almost as pathetic as what I'm hearing right now. Okay, we got one more test to write, which is back, go away, back here in the preference controller. We need, when we get a new preference, when some object announces has Ruby source, I don't actually need to use any mock objects. I just say the new file, since we're in row 0, what we expect is whatever source came in this new file gets crammed onto the front or replaces the 0th element of the original sources. And then we assert that the actual sources we see are equal to the expected sources. So we'll see that it's actually changed. And once again, we run the test. Okay, and it fails. And this is kind of the neat thing about assert 2.0. You'll notice the assertion said self-current sources equals expected. If the assertion fails, assert 2.0 goes and reruns all the subtrees of that expression and shows you the value of each one. So it provides more diagnostic information usually than you would get from assert equals. So in this particular case, the starting sources were an empty string and an empty string. These are actually Objective-C strings, not Ruby strings, but for most purposes, they're the same thing. So we started out with 2 empty strings, which I can't show you. We expected temp mumble Ruby put on the front, and here we see it wasn't, and that's because we didn't write any code yet. So down here, oops, wrong file. So when we receive has Ruby source, what we are supposed to do is we're supposed to change that array entry. Now, the window I was showing you originally is a preferences window. And Cocoa's got this nice facility where you just cram values into an array, and it takes care of serializing, takes care of putting them on disk and all of that saving preferences stuff. But to accomplish that when you're dealing with arrays, you can't just change a single element. You actually have to pull out an element, mess with it, and put it back in. And so I've written somewhere here a little method that I use to update these things. So update changed object at index. And the index comes from the notification, and it's the row. And then that pulls out a preference object, essentially that entire row of stuff. And I'm going to change the source to notification source. And that should pass. But not yet, too soon. Because the danger with mock objects, of course, is I've written behavior in this controller, I've tested this controller, embedding into the test assumptions about how this controller is going to work, and I've embedded controllers. Now, see, I've embedded assumptions into the test for this controller about how that controller is going to work, and I've embedded assumptions into the test for that controller about how this controller is going to work, and we don't know yet if they actually play together. Now, many people would write large, in the Rails world, you'd write a water or a selenium test, but I actually find it sufficient, a heretical person that I sometimes am, to simply use the checklist of things I said I implemented, use the tests as a checklist, like to tell me things like clicking on rows, columns that aren't source columns, and so on and so forth, and just do a pass manually. Tell them I'm an authority on testing, Kay. Oops, we're done. But just let's try it. Not yet, because we don't know. Oh, shut up. We don't know that it actually saved it. Now cut it out. Okay, the timer is very insistent. Can you throw that away, please? I'm done. I can, you know. Questions? Now nobody's going to ask. You just wanted to make sure. Yes?
You mentioned you were starting by writing the cases, the tests into the exceptional cases before the happy path. What's the rationale behind it?
There's no particular rationale except, I guess there are two things. One is most of the time when I'm doing error handling, the structure, the method looks like, if something bad happens, return. If something else bad happens, return. So the error handling kind of sits at the top, and then the real code is on the bottom. So this is sort of a way of being anal retentive and writing it in order. The other one is that I want to avoid now, normally when I'm writing tests, I wouldn't write all the tests first and make them pass one at a time. I do it more like write one test, make it pass, write the next test, make it pass. When you write the main case and make that pass, all of a sudden you kind of feel done because, there will be no errors introduced into my program by those users. They will treat it with the respect it deserves. And so you tend to underthink the error cases, but if you do them first, you're more likely to think properly. Thank you.